Alright, so for this video, we will be discussing paper 3 for October-November 2025, paper 3-2. Right, so let's have a look for question number 1, part A. They want us to sketch the graph of y equals to modulus x plus 3a, where a is a positive constant. Right, so to sketch any modulus graph, what I usually do is like, I'll ask my student to draw the original graph first, where y is equals to x plus 3a. So I need 2 points, right, to draw the original graph. So I will let x equals to 0, then you'll get y equals to positive 3a. Alright, so you'll be having y equals to positive 3a. And then if you let y equals to 0, then your x-intercept will be negative 3a. X equals to negative 3a. Alright, so when I want to sketch this diagram, what am I going to do is like I'll try to sketch these 2 points first. Right? Okay, so let's start. Okay, so you can try to make your axis. Then measure your diagram, okay, with a proper ratio. So for me, I will treat the 3a as 3 unit. Alright, so this is my 3a. Then same thing happen for the x-axis here. I'm also having 3 unit for negative 3a. Alright, so original graph, by right, it should be looking something like this. So you have to sketch the graph, pass through these 2 points. So this is the original graph. Okay, but when we want to put a modulus, okay, when I want to put a modulus, that means this part of the graph, which is the negative part, you have to reflect it up, become positive. So if you try to reflect it up, become positive, then it will become something like this. Alright, but of course, if you want, you can try to measure the ratio and so on to reflect the graph properly. Right? Okay, so by right, this V-shaped graph here is actually your y equals to modulus 3 plus x plus 3a. Alright, so this is one of the method where I try to draw the original graph first and then I reflect the negative part become the positive. Okay, so let's have a look for part B. Hence or otherwise solve the inequality for this particular part. Modulus 3x plus 3a is greater than a minus 2x. Right, so for this kind of question, if you want, you can try to draw the diagram to visualize the answer or to get the answer directly. For me, I personally don't really like to sketch the diagram and decide the answer because of there are some restriction. Because if I try to sketch the diagram, then basically you need to make sure that the ratio that you're using is very accurate so that it didn't misleading. I mean your graph didn't misleading to some other wrong answer. Then for me, I personally still prefer to sketch the diagram first. To solve the equation first, where I try to assume the inequality become equal sign first because I want to get the intersection point or the critical value first. Alright, so if I want to find out the intersection point or critical value, you need to know that for any modulus function here, I can actually write it out become 2 pieces of non-modulus form. The non-modulus form, one is x plus 3a, another one is negative x plus 3a. So to find out the intersection point or the critical value, I try to solve it first. So I'm having a positive x plus 3a is equals to, our equation is a minus 2x, right? So another part of the critical value, I want to solve it by using negative x plus 3a, then equals to a minus 2x. Alright, so let's try to solve for the value of the x here. I'm having 3x equals to negative 2a. So my x particularly is equals to negative 2 over 3a. Then same thing happen for the other equation here. I try to solve the equation, try to get the value of the x. So from here, I'll get x equals to positive 4a. Okay, so these two value of x basically means the critical value. Alright, so if you try to sketch a diagram just now for a minus 2x, then you might see, I'm not 100%, you might see these are the intersection point. But sometimes when you draw it, you might have only one intersection point. Alright, so for me, I don't like, that's the reason I don't like to draw the graph to solve. I prefer to solve it directly. Okay, so first step, I try to get the critical value first. Then after that, I want to decide my answer part by part. Okay, so I'm having my original inequality, right? So let's recall again. Our original inequality in this question is x plus 3a must be greater than a minus 2x. Okay, so I'm having two critical value here. I need to try it part by part. So when I want to try part by part, I try to determine it in this way. I separate it into three different parts according to the value of the critical value. Right, so you're having three parts here. This is the first part. Then the center one is the second part. Then the last one is the third part. So let's have a look for the first part first. We try to use any value of x that's smaller than negative 3 over 2a. So maybe for me, I'm using x equals to negative a here. Because negative a is smaller than negative 2 over 3a, right? I substitute x into this inequality. Then I try to compare the inequality here. So negative a plus 3a, you're having 2a, right? So modulus 2a greater than a minus 2 multiplied with negative a. So you're having a plus 2a. A plus 2a, eventually you get 3a. So you ask yourself, after you substitute this particular value, is this inequality a correct answer or wrong answer? So this inequality, very obvious, is false, right? Because 2a shouldn't be greater than 3a. So that means this is not a correct answer here. Right? Then after that, I want to use a value that is between this one. So for me, maybe I try to use x equals to 0. Substitute x equals to 0, you're having modulus 3a for the left-hand side of the inequality greater than a. So if you try to have a look for this inequality here, is this inequality a correct inequality? Yes, right? So that means the answer from this part is correct and I want to accept answer from this part. Then the next one, we are going to try out for the third part. So maybe I use x equals to 5a. Substitute into the inequality here, you're having 8a on the left hand side, modulus greater than a minus 10a. So a minus 10a, you're having negative 9a. So modulus 8a is positive, right? So positive 8a greater than negative 9a, which means this is also a correct answer. So from here, out of the three parts here, which part gives you the correct answer? These are the parts that give you the correct inequality, right? Therefore, your final answer should be x greater than negative 2 over 3a. So this is the method that I usually use to find out the answer, the range of the x, especially in the inequality for modulus function. Alright, so I try to find the critical value first, determine the answer according to the parts, then write out the correct answer for the correct partner. Right? So this is how we solve question number. Right, and so we are now at question number 2. They want us to solve this equation. Give your correct answer to 3 significant figures. Alright, and this answer involve indices, right? Okay, so let's write out all the equation first, and we need to use some property of the indices to solve this question, right? Okay, so first of all, we are having this first indices here, x power x, 2 power x plus 1. Alright, so for 2 power x plus 1, we are going to use the property that we learned earlier, which involve this one. If we are having a power m plus n, then you can separate it become a power m multiply with a power n. So this is what we exactly want to apply for this 2 power x plus 1. Alright, so if I have 2 power x plus 1, if I want to separate that, it will become 2 power x multiply with 2 power 1. Okay, then I'm having 4, just copy the 4. Alright, so for this part, you can see that there are some indices also. There are two indices that we are going to apply here. Another one is this one. If I'm having a power m minus n, then basically you have to separate become a power m divided by a power n. Okay, then another one is about the power of power rules, where if I'm having a power m with power n together, multiply them, you can rewrite your equation become a power m with an n outside, or you can also put the n inside with the power m outside. So they're either one of them. Alright, so let's have a look for this particular part here. I'm having 3 power 2x minus 3. Okay, so 3 power 2x minus 3 here, I want to separate it become something like this. I'm having 3 power 2x divided by 3 power 3. Minus, right? Therefore, I can put it become divide. Okay, then after that, I still have this one. power 2x. So power 2x, I want to apply this particular property here. I want to separate either into this part or either into this part. So for me, I want to keep my number inside the bracket. So if I want to keep my number inside the bracket, that means the 2x here, I want to write it become something like this. 3 power 2 with the x outside. Okay? And after that, I multiply all the number together first, separately. So for this one, it's a 3 multiplied with 2. So 3 multiplied with 2, you're having the 6. 6 with power 2, 6 with 2 power x. Okay, then for this part, I try to expand everything. 4 is a 4. 3 cube is a 27, right? So you're having 4 over 27. Okay, so what is a 3 square here? So 3 square in the bracket is a 9. So you're having 9 power x. Okay, then what I do now is I try to group all my term with the power x at one side. So as an example, if this is 9 power x, I want to bring it here. So I'll be having 2 power x divided by 9 power x. Then equals to 4 divided by 27 multiplied with 6. Alright, so this is what we have until this step. And I hope that you are still clear about it. Okay, then after that, what do I have from this part? If I try to simplify it, okay, so 4 over 27 times 6, 4 divided by 27 times 6. You'll be getting 2 over 81. Alright, so I'm having 2 over 81. Okay, then for the left hand side here, I'm going to use another property where if I have two same power, let's example like a power m divided by b power m, you basically can take out the power m by leaving a over b inside the bracket because both the power are the same. So what am I going to do here is I want to make it like this. So 2 over 9. Both of them are having power x, right? So this is the power x outside. Okay, and after I make it into this pattern, then I will take ln both sides so that I can bring the x downwards. Alright, then here I will have the property like this. If I'm having ln a power n, you can write it become n ln a. So to make the n become the number in front, so I need to take ln both sides here. Okay, so please take ln both sides. If you take ln both sides, this is what you have. Ln 2 over 9 equals to ln 2 over 81. And the x is in front here. Okay, so eventually, to get the answer for the x, what you need to do is like you just need to move your ln 2 over 9 to the other side. Okay, and use calculator to help a little bit. Try to rephrase your answer, correct the 3 significant figure. So this is what I get. Then correct to 3 significant figure, the answer should be 2.46. So this is how I solve the question number 2. And then if let's say some of the students, right, they always feel confusing when I want to solve this kind of question, what I usually do is that I try to group it into this pattern where I'm having a number. Then I try to group all the number with power x will be on the left equals to a number on the right hand side. Then only I start to take ln for both sides. Okay, I believe that there are some students they prefer to take ln very earlier at earlier steps also can, but just make sure that you don't do careless mistake. So for me, I usually will target it as to get this particular pattern of the final step before I take the ln, which means that I want to have a number with a power x equals to purely number on the right hand side. Only I start to take ln. Then I feel that in this way, you will get the answer. At least you have a direction on how to rephrase your equation and get the answer. Alright, so this is how you solve. Alright, so question number 3. You are given a diagram. Then they tell us that the shaded region in the diagram bounded by a line and a circle represent the complex number z satisfying these two complex numbers of the locals. Right. Okay, then they say the point P shown in the diagram is one of the point of the intersection of a line and also the circle. So find the complex number represented by the point P. Give your answer in this pattern, x plus yi where x and y and real and exact. So highlight the keyword real and also exact here. Alright, so from the diagram, you can see that P basically is an intersection point. They also tell you clearly here, point of intersection of a line and also the circle. So let's recall back in maybe AS syllabus, when you want to get any intersection point between two lines, between one line and one curve, then how you basically get the intersection point? You try to solve the equation simultaneously, right? Okay, and now for this question here, if you have a look for the Argand diagram that we have, basically we can easily form the equation in this Argand diagram. So as an example, for this particular line, it is a vertical line, right? So for the equation of vertical line in coordinate geometry form, how are we going to write out the equation? So it should be x equals to what? X equals to 2 for this case. Agree? Alright, for vertical line, the equation for coordinate geometry will be in terms of x equals to 2. Then how about we form the equation of the circle? So to form this equation of the circle, you already know the center. So what is the center here? How you know the center? Basically, it is written in this inequality. So 3 plus I is a center, where it basically tells you that 3, 1 is a center. I means 1I, right? So 3, 1 is the center. And how about the radius? In our locus form of the complex number, okay, the 2 here basically is the radius. Therefore, the radius is equals to 2. Alright, so first, you're having x equals to 2 as a first equation, as a line equation. And what is the equation of the center here? So to write the equation of the center in the standard form, you'll be having x minus 3 squared, then plus y minus 1 squared, equals to radius 2, right? 2 squared. And this is your second equation. Since P is the intersection point between the line and also the curve, therefore, we solve the equation simultaneously. Excuse me. So I substitute 1 into second equation. Alright, so what do I get here? So when substitute x equals to 2 into the equation here, you're having minus 1 square. Minus 1 square, you have a 1. Then plus y minus 1 square equals to 4. Okay, so further expand your equation here to get the equation, the value of the y. Okay, so if I'm not mistaken, or I didn't do any careless mistake, by right, this one is your equation of y. Then to get the value of the y, of course, you have to solve it, right? If you try to have a look for this, excuse me, quadratic equation, I don't think that we can factorize it. Alright, so what we do is like we try to solve it by using the quadratic equation, where you should be having negative b plus minus b square minus 4ac. So what is your b square here? It will be negative 2 then square. Okay, so b square is negative 2 square minus 4, a is 1, c is negative 2. Then divided by 2a. Okay, then after that, we try to further simplify it. I'm having 2 plus minus 2 square is a 4, right? So 4 plus 8, 4 times 2 is 8, is a 12. Divided by 2. Then if you try to further simplify it, you'll be having 2 plus 2 third 3. 4 times 3 is 12. So square root 4 is a 2. So 2 third 3 over 2. And then another one is 2 minus 2 third 3 over 2. Okay, so you yourself have to ask which is the correct answer that you should accept. So by right, you should be accepting here. This one tells you that y should be negative. Correct? It is below the x-axis, therefore y should be negative value. So definitely, this is not the correct answer, because this value is a positive value, and we are looking for the negative value here from the diagram. So this should be your correct answer for the y. And you successfully get the y coordinate and also the x coordinate for the point P, but they want you to write it out in the complex number form. So don't forget to rewrite your answer again, where P is equals to 2 plus, then your y is 2. Oh, sorry. So for this one, you can further simplify. Okay, so for this particular part, you can further simplify all the 2 here. It will become 1 minus 3. Therefore, your y here, you can write it become 1 minus 3 with I. Okay, so please make sure that you rewrite it in terms of x plus yi form, yeah, because the question requested for x plus yi form. This is how we get the complex number p. Okay, all right, then let's continue further. For part B, they want you to find the greatest value of argument z for points in the shaded region. All right, so the greatest, highlight the keyword greatest. Then argument z means the angle of argument. And you should know that argument z basically means that the argument of the z that we measure from 0 plus 0i. So 0 plus 0i means the origin. Okay, so you are trying to measure the argument of the z from the origin. Okay, then they're asking for the greatest value. So how to find out the greatest value? So let's take some example here. Let me fix the point at the origin first. Z can be any point in the circle, in the shaded region. That is the Z. Let's say my Z is here. Let's say this is my Z. So if you try to draw a line from 0, 0 to the Z, okay, then this is basically the angle, the theta or the argument. Okay, this is argument Z. Can you see that? I draw a small arrow here. This is the argument Z. Okay, so this is the argument Z. I hope that you can see that, Alright, okay, so this argument Z is having a negative value because we measure it from positive x-axis and go down in clockwise direction. So clockwise direction, the measurement will be negative. So negative shouldn't be a biggest angle. Alright, so if you try another point for the Z, how about if let's say I try to plot any point on the Z, maybe somewhere here, this is the Z. Then to get the argument, you draw a line from 0, 0 to the argument, to the point of Z, sorry. So this one basically is the argument of Z from 0, 0, from the origin, right? So do you think that is this the argument that is the greatest in the shaded region? No, also, right? So you can try to move, use a ruler to try to shift your point higher and higher and higher until the ruler touch the shaded area at last point. Okay, so if you touch the shaded area at last point, the point should be more or less somewhere at this part one. Okay, yeah, so you have to understand what's the meaning of argument Z. Basically, it means that the angle from Z, right? So the angle from Z to from the origin. Okay, all right. So if I try to draw a line here, this might be my greatest argument of the Z. Okay, then now if I have this line here, this is the Z, then we should know that this is actually a tangent. This particular line is actually the tangent of the circle at the point Z. Okay, so if you know that this line is a tangent line, then you should also know about the property of a circle and also the triangle, where center to the Z is 90 degrees with the tangent. Alright, so you can form a triangle here. Okay, so I draw a triangle here. I hope that you can see clearly. Yeah, alright. So again, I just want to recall back. This center point here is 3, 1. Alright, and now what is the argument that you want to get? So the final answer for the argument Z is this one, blue color angle. Okay, how can I get the answer for the blue color angle? You might need a little bit help from some other angle and also the triangle that I draw here. Okay, so first of all, I know that this particular length is the radius, which is actually a 2 cm, 2 units, sorry. Okay, and after that, for this hypotenuse here is actually the square root of 3 square plus 1 square, because it is the hypotenuse. Okay, it is the distance between 0, 0 and 3, 1. Okay, so to find the distance from 0, 0 to 3, 1, basically it is square root 3 square plus 1 square, which is square root 10. Alright, okay, so I have this triangle here. By having this triangle, I can actually form the answer of this theta, purple color theta in the triangle. Alright, okay, so let us start some calculation here. And before that, let me move all my answer down first. I need space. Right, so this one I move it down for part A. Okay, then this part I also move it down. Okay, so this is the answer for part A. Just to recall back first, this is the part A. And now for part B, I want to show it by using the diagram. Okay, so like what I told you just now, the blue color angle is the greatest argument Z. Okay, the blue color angle. So to get the blue color angle here, I can find out the theta in purple color and also maybe the alpha in red color. If I successfully find out the alpha and theta, if I add them together, then I will get a blue color angle, right? Okay, so how can I get the theta? According to this green color triangle that I draw, theta, sine theta means opposite over hypotenuse, right? So I'm having the value of sine theta should be equals to 2 over square root 10. Okay, and after that, what's the value for theta here? So the theta should be equals to sine inverse 2 over square root 10. Okay, so all this value getting from the green color triangle, right? Okay, then now let's have a look for the alpha. What is the alpha related to? Basically, alpha is the argument of the 0.31. Because you can see, if you want, you can actually see there's a red color triangle here also, right? Okay, then the height here is a 1, then the bottom here is a 3. Okay, so tangent alpha is 1 over 3. So you can write out from here, the tangent alpha is basically equals to 1 over 3. And your alpha should be tangent inverse 1 over 3. Okay, then eventually I want to get the blue color angle. So for this blue color angle, very obvious, it is the argument Z, or the greatest argument of Z. You have to take theta plus alpha. So the theta is sine inverse 2 over sec 10. Okay, then plus alpha, which is tangent inverse 1 over 3. Then of course, you need to use a calculator to help you a little bit on this. And by right, the answer that you get should be 57.7 if you want to put it in degree form, in degree. Or if you don't want, you can keep it to radian, which is 1.01 radian. Let me have a look for the request of the question, what they want. They just say find the greatest value of argument Z, right? But they didn't mention what is the unit, so you can keep your answer in any format. Alright, so if let's say 3 significant figure, then it will be 1.01 radian. So for degree, it should be up to 1 decimal place of accuracy. This is how we actually get the greatest value for the argument Z in the shaded area. Alright, okay, so this is how we get the answer for part B and solve. This is how we solve the question number 3. Alright, so let's have a look for question number 4. They want us to find the exact value of this integration. Highlight the keyword exact value. This one tells you that your final answer must be in the surd form, pi form, but cannot be in decimal number, yeah? Right. Okay, so let's have a look for this question here. We are having two parts of function. I'm having function x with another function which is tangent inverse x. It is a product of two different functions. And then we can consider to use integration by part to solve this question. Alright, so just recall. What is integration by part and what is the formula that we have here? Okay, so integration by part is you're having the question which is integrate of u dv equals to uv minus integration of v du. Okay, this is a general formula for the integration by part. Right? Okay, then this part basically is the question. This is the question part. Right, so we have to separate our question into two parts. One is u. Another one is integration of dv. Integration of 1 dv. Okay, then to determine which one is u, which one is integration of dv, we will have some simple rule here. It is LIATE. Okay, so where L is log function, I is inverse trigo, A is algebra, T is trigo, then E is exponential. If your function belongs to a higher group, then it will be the U. If your function belongs to the lower group, then it will be the integration of 1 dv. Okay, so let's have a look for our question here. We are having x. So x belongs to algebra, which is A. And then this one, tangent inverse belongs to inverse trigo, which is I. So according to A and I in our group here, I is higher than A, right? So I should be the U. And then A should be the integration of dv. Okay, so after you decide already or you determine already, then you can straight away write out the step first. So I let U equals to the inverse function for this one, which is tangent inverse x. Then the integration of 1 dv will be basically equals to the integration of x dx, because x is at the lower group, right? So we come and copy down all the side symbol for the integration for the x. Definitely for this part, you have to apply differentiation. So how can I differentiate tangent x? So you recall back to chapter 4, yeah? Differentiate tangent x, you're having 1 over square the x with 1 square. Okay, then for the integration part here, integrate 1 dv, you get a v. Integrate x dx, you'll be having x squared over 2. So I didn't put plus c here because for me, I just want to put all the plus c at one side at the last step after I complete everything in integration. Okay? Alright, so I'm having this and that. Then we can follow this formula to get the integration answer. So let's start first. I'm having the question 0 to 1 for x with tangent inverse dx. According to the formula, I'm having uv. What is the u? U is tangent inverse x. What's the v? V is this one. So if I multiply them together, I will be having x squared over 2 multiply with u, which is tangent inverse x. And this is basically the term that we have applied the integration, and you have to put in the value of the limit, which is 1 to 0. Then see the negative here, right? So minus. Integrate, copy the limit as well. Okay, then now I'm having v du. What's my v? This is the v. X squared over 2. This is your du. You can get it from here. So for du, you can move your dx to the right hand side. Therefore, your du will give you 1 over x squared plus 1 with dx at the back. Okay, alright, so this is what we get it directly from the formula. And now let's continue and proceed with the next integration. Okay, so for this part, you have to substitute in the limit of 1 and 0. So substitute limit 1. So you're having 1 over 2. Sorry, you're having 1 over 2. Then tangent inverse 1. 0 substitute inside, you get everything as a 0. So I don't write out the detail. Okay. Then for this part, before I can integrate it, I want to take out the constant, which is actually the half. Alright, so I feel that the half is quite troublesome. I prefer to take out the constant in the integration part. Okay, so this is what you have. And how can I integrate this one? If you have looked for this particular term here, it is actually the improper fraction. So I want to make it become proper fraction first. If you want to make it become proper fraction, there are two ways. Either you apply long division, then find out the remainder. If not, then you can just rephrase your equation a bit. So later I will show you how. Alright. Okay, so let's come back to our term here. Tangent inverse 1 will give you 45 degree. But in all the integration and differentiation, you cannot keep your answer in degree. So 45 had to make it become radian, which is pi over 4. Okay, so for this part, I lazy to apply long division. I just want to rewrite my equation a little bit so that I will have x squared plus 1 and my numerator. Okay, so I already have x squared, right? I already have x squared. Then I want to put a plus 1 so that I have x squared plus 1, similar to the bottom. Okay, but when you are adding a 1 on top, you have to also minus the 1 on top so that the equation is still balanced. Okay, alright, then next step, I'm having this one as pi over 8. Okay, so for next step, I want to group all the x squared plus 1 together. Then this one, it will become 1 over x squared plus 1. Okay, so this number 1 here, I will separate it out, become another fraction. Then very obvious, this one become 1, right? Okay, then I'm having 1 over x squared plus 1 squared, which is x squared plus a squared. Your a is a 1 here. Okay, then now, for integration of 1, no problem for you to get the integration for 1. And then how can I get the integration for 1 over x squared plus 1? I don't know whether you still remember or not, but of course you can always refer back to your formula booklet. I think it is provided in the booklet. Okay, so if you have a look here, this is integration, yeah? So when you want to integration of 1 over x squared, 1 over x squared plus a squared, this one. 1 over x squared plus a squared. Your a is a 1 in our case here. Okay, so you're having 1 over 1 tangent inverse x over 1. Okay, so let's go back. 1 over 1 tangent inverse x over 1. Alright, then if you continue further from here, what do I get? Okay, so let's start. I'm still having the same thing. Oh, I forget to put in a limit, sorry. Okay, so I'm having pi over 8. Half is a constant, I just try to copy it. Integrate 1, you get an x. Then integrate this one, your a squared, x squared plus a squared. So your a is a 1. The formula is 1 over a. 1 over a is a 1. Okay, then tangent inverse x over a, which is also x over 1, which is also x. Then you have to put in the value of 1 and 0. Okay, yeah, so now you just need to make sure that you substitute the limit and didn't do careless mistake. Don't do careless mistake, yeah? Okay, so x is a 1. Tangent inverse 1, you'll get pi over 4. Minus x0 is a 0. Tangent inverse 0, you also get a 0. Okay, so I think from here, you should try to simplify your answer. So 1 over 8 pi. Okay, so plus 1 over 8 pi minus half, then plus 1 over 8 pi. If you simplify your answer by right, you should get 1 over 4 pi, then minus half. And we should keep your answer in the pi form like this, because the question requested for exact answer for this integration. Okay, so this is how we solve question number 5. Alright, so question number 5. It is given that I'm having a function of fx, where f and g are polynomials. Show that x minus a is a factor of f prime x. Okay, so first of all, since they want us to show that the x minus a is a factor of f prime x, right? So let us try to find out x prime x first. Okay, so this is my original question, original equation for the function f. If I want to find out the prime, f prime x, so you have to apply differentiation, right? So to apply differentiation, you're having the product of two algebra or two terms. This is the first term. This is the second term. When you're having a multiplication of two variable or two polynomial, and you want to find the differentiation, you have to apply the product rule. So for product rule, it's like I treat it as first bracket and also the second bracket. Some students prefer to make it as u and v, also can. Alright. Then to find the differentiation, what I do is like I try to use the product rule, where the step is I copy the first bracket. So I copy the first bracket, differentiate the second. So it becomes g prime x. After that, I need to differentiate the first bracket, then copy the second. When I differentiate the first bracket, I'm having 2x minus a, because I put the power in front, right? Then power minus 1. Then copy the second bracket means I just copy the gx, right? And now, to prove that x minus a is also a factor for the polynomial, what I need to do is I need to substitute the a inside the function f. Okay, so I need to substitute the a inside the function f. And if I do so, what do I have here is a minus a, then I get a 0, multiply with gx, g prime x, then plus 0, a minus a is also a 0, multiply with gx, right? So everything will be a 0. So from here, according to the factor theorem, when you substitute any value inside the equation and you get it equals to 0, then basically it means that x minus the a is a factor of the f prime x. Okay, and next, part B. Now, it is given that x minus 3 squared is a factor of this particular function where p and q are constant. Find the values of p and also the q. Alright, so for our question here, right, in the first part, since they tell us that, oh, we are having the function fx, then when we have this pattern x minus a squared, if you try to compare it with part B, it is something like x minus 3 squared. So the part A and part B basically are linked. Alright, so you can try to have a look here. Oh, so just now they write fx equals to this one. And then x minus a is also a factor of f prime x. So same thing happen here. If you're having x minus 3 squared, okay, then it will be having x minus 3 is also a factor of f prime x. Okay, so we try to link these two parts together. Right, just that for now, what is our function f in part B? So let's copy out first. So let's try it out here. Function fx for this question is 2x power 3 minus 4x squared plus px plus q. Okay, so from first part, you should know that x minus a is a factor of fx. X minus a is also a factor of m prime x, right? Okay, so I have to substitute what value? If you're having x minus a as a factor, then you substitute a inside your function. So now we are having x minus 3 as a factor, therefore I have to substitute the value of 3. So let's have a look for f3 equals to 0. And what do you get for f3? So you're having 2 with 3 power 3 minus 4, 3 squared plus 3p, then plus q equals to 0. Alright, then after that, you try to simplify this particular equation here, expand everything. By right, if you didn't do any careless mistake, this equation will lead you to this one, 3p plus q plus 18 equals to 0. And I will make this as the first equation. Okay, now I need second equation. So for second equation, in the part 1, they tell us that x minus a squared, right? For x minus a squared, the x minus a is also the function, the factor for f prime x. So let's try to form an equation by using the f prime x first. Okay, so f prime x is what? The differentiation for the function f. Okay, your function f is this one. Please differentiate it. So you're having 6x power 2. Then 2 put in front, you're having 8x. Power minus 1 become 1, right? Then plus p. And then you should also know that if you substitute a 3 into the f prime x, you are getting a value of 0 as well, because x minus 3 is actually also a factor of f prime x. Okay, then same thing happen here. You try to substitute the 3 into your equation. Oh, then this one you can directly get the value of the p. Okay, so 9 times 6 is 54. Minus 8 times 3 is 24. So your p should be having a value of negative 30. Right? So after you get your p, then you can get the q by substituting it into the first equation. Then what is your q? So 3 negative 30 plus q plus 18 equals to 0. So the value of q that you should get here is 72 if I don't do any careless mistake. Alright, so rewrite the answer again. P is negative 30 and q is 70. Okay, so this is how we solve question number. So we are now at question number 6. Part A, by sketching a suitable pair, we need to sketch a pair of graphs. They want us to show that this equation has exactly one root in this interval. So that means we need to sketch two graphs within this interval, and we need to show that there's only one intersection point for the two graphs that we sketch. Alright, because when they say there's only one root, so one root means there are one intersection point for the graph that we sketch. Right, so what we need to sketch here is you can sketch y equals to cotangent 2x. Now another graph that we draw is this one. So y equals to 2 sine 2x minus 1. Okay, right, so for me personally, I don't really go and memorize the graph, but I just memorize the basic graph. So as an example, for cotangent 2x, right? Okay, so for cotangent 2x, it is coming from 1 over tangent 2x. Okay, but before that, what I do is like I try to sketch from the beginning first, which is the basic graph for tangent x. Right? So how can I sketch for tangent x? The tangent x graph looks something like this. So the original graph might look something like this, where you are having from here until this part, and then this is the original graph for tangent. Then of course they are repeated cycle, right? Okay, so I'm having 0. This is basically pi over 2. Alright, and then if you want to expand further, then you should know that the next part will be from pi over 2 until 3 pi over 2. Then this is basically, this is the pi, then this is 3 pi over 2. Alright, okay, so this is a tangent x. And after that, if I want to sketch tangent 2x, so you should know that tangent 2x means that you are having a stretch in the x direction with the stretch factor of half. So that means you need to multiply all the x-intercept with half. Multiply it with half. So as an example, when you're having this line originally as pi over 2, right? If you multiply with half, then it will become pi over 4. Then for the pi here, if you want to multiply with half, then you'll be having pi over 2. Then this one will become 3 pi over 4. Alright? And in short, we are only interested for this part of the graph. For our final graph that we want to draw, because they're asking us for 0 to pi over 2. So this is what you have for 0 to pi over 2. But this is not our final answer yet, because, sorry, I start from here, yeah, 0 until pi over 2. So this is the graph for tangent 2x. And now my final graph will be 1 over tangent 2x. How can I sketch 1 over tangent 2x? So basically, you need to have some basic idea on the reciprocal function. How you sketch the reciprocal function? When you are having your y value equals to 0, then 1 divided by 0, you'll get the infinity. So as an example, this point, you're having y equals to 0, right? So that means if you take 1 divided by 0, you'll get a very large value where you should start from infinity. So that means your graph will be somewhere starting from the top. Okay, so the 0 will give you this infinity here. Alright, okay, then after that, what about the infinity? Okay, so at here, your y is equals to infinity. So you try to imagine if you take 1 divided by infinity, what you get? You get a very, very small value, and we assume that it is equals to 0. So that means at pi over 4, it will be your x-intercept. Okay, so pi over 4. Right, then same thing happened here. You're having infinity. Okay, so 1 divided by negative infinity, you have a value very, very small, which is close to 0, and it is coming from negative side. So that means if positive infinity coming from here, then negative infinity will be coming from this side. Okay, so this is how your graph will look like. And after that, for pi over 2, you can see that at this point here, y is equals to 0. So try to imagine, if you take 1 divided by 0, you'll get a very, very large value, and it is approached from negative side, which means that if you want to draw the negative infinity, if you draw the infinity, it will be going to the negative infinity side, which is this one. So if you try to join all the small details here that we try to figure it out just now, so this is how your graph look like for 1 over tangent 2x. or we can call it as y equals to cotangent to x. Alright, but of course, some students, they don't like to memorize all the steps here. Then of course, you can purely memorize the graph that you have. Okay, so for me, usually what I do is like I try to sketch it from scratch, from the basic function. So like for this one, the basic function is basically tangent, right? Then I try to memorize the reciprocal function and also the transformation of the graph. Alright, so this is what we have for cotangent to x. So this is the first graph that I want to include in my answer later. Alright, okay, then after that, let's have a look for 2 sine 2x minus 1. Okay, so 2 sine 2x, the original graph come from sine x from 0 to pi over 2. Okay, so let's have a look here. My original sine graph will look something like this. Okay, so this is 0. This is pi over 2, and this is pi. Again, when I multiply the 2 inside the basic function becomes sine 2x, you are having a stretch in x direction with a stretch factor of half, which means that all the x value here you have to multiply with half. Therefore, this one will become pi over 4, and this will become pi over 2. Okay, alright, then originally you are having a maximum point is positive 1 and the minimum point is negative 1. According to our request, our question, right, they are asking for the graph from 0 to pi over 2. That means I only want to consider the graph from 0 until pi over 2, which is this one, right? Okay, then after that, I want to multiply a 2 outside the basic function. When you multiply the 2, it will affect your value of y because it is a stretch in y direction and the stretch factor is 2, which means that the value affected will be the y value here. So the 1 here will become a 2. Okay, and after that, you need to have a minus 1 outside the basic function as well. The minus 1 here is a translation. Okay, so it's a translation in y direction, and you are going to move the graph 1 unit down. Therefore, when you want to sketch the graph 1 unit down, then how will your graph eventually look like? Okay, so let us try to draw it out clearer here. Our original x-axis will be moved down for 1 unit. Okay, so that means your graph will start from 0. The original maximum point is a 2. When you move it down 1 unit, it will become 1. Alright, and then your graph should look something like this, where you should know that this is 0. Then this one is basically pi over 4. And this is basically pi over 2. Alright, and this is what we have for y equals to 2 sine 2x minus 1. But they want you to sketch this pair of graph in the same axis. So let's combine them together in the same axis here, right? Okay, so this is what we have separately for the pair of graph that we want to sketch. Alright, so if I try to combine both of them together, alright, so your final graph might look something like this. Okay, so let me try to draw it out first, yeah. So what do I have here is so this is the line y equals to negative 1. Okay, then according to what I have here, I'm having this is negative 1. I'm having a 1. Then it will pass through this point where it is pi over 4. Then after that, we're having another point here. Okay, so which is actually pi over 2. So if you try to sketch it, this is what you have for 2 sine 2x minus 1. So I label it as y equals to 2 sine 2x minus 1. Okay, then after that, I will sketch my tangent graph, cotangent graph by using the purple color, it will pass through 0 and pi over 4, which is this point. And then the line pi over 2 is basically the asymptote for cotangent 2x. So my graph will eventually look something like this. Okay, so I hope that you can see clearly. Then I will label this as y equals to cotangent 2x. Alright, then since they ask us to prove that there's only one root, so what we need to do is like we need to make a simple conclusion. So according to the graph that we draw, right, we only see one intersection point. Therefore, the conclusion that we should make is something like this. So you can say that we have only one intersection point can be seen. Okay, so we have only one root. Within the range or the domain that we draw. Right, so this is how we solve the question for 2 marks. Right, so just make sure that when you are trying to sketch a diagram, right, actually this part you can just skip it because this is for understanding purpose. I try to sketch it from the scratch. So in exam, you just need to show this final graph here with the simple conclusion about what they want you to prove. All right, this is what we have for part A. Okay, then let's continue to part B. Right, so for part B, they want you to show by calculation that the root lies between these two intervals, where x is between 0.4 to 0.6. Okay, so let's have a look for part B. So my original equation is this one, yeah. Our original equation is cotangent 2x equals to 2 sine 2x minus 1. Then for me, usually this kind of question, I'm using the sign change method, right? So the sign change method means that I need to move and change my equation become a function. So either you move all the terms to the left or either you move all the terms to the right. Both also okay. Right, so for me, what I'm doing here is I try to move everything to the left hand side. So I'm having cotangent 2x minus 2 sine 2x, then plus 1. Okay, then what they want us to prove is the root is between 0.4 and also 0.6. So what am I doing here is I substitute 0.4 into our equation here. So 0.4 times 2, you're having 0.8. This is also 0.8, then plus 1. Okay, then after that, you substitute 0.6 as well. Okay, so try to use calculator and press the answer. Okay, then if you didn't do any careless mistake, then by right, this answer should be 0.537, correct to 3 significant figure. And then the second answer should be negative 0.475, correct to 3 significant figure. Okay, and then basically what we do here is you must see a sign change. So no matter just now you move all the term to the left or all the term to the right, there must be one positive answer and also one negative answer. Just in case, if you can't get the answer here when you press the calculator, can you please double check and make sure that your calculator is in the radian mode. It must be in radian mode but not degree mode because all this value in the trigo basically denote the radian, not the degree, because you can't see the degree sign, right? So all these basically are radian. So you have to put your calculator in the radian mode to get this answer, right? And very obvious, you can see that there's one positive value and one negative value here. This is what we call a sign change. So after this, I will make a conclusion again. So sign change can be seen between f0.4 and also f0.6. Alright, so basically this also tells us that we are having the root lies between 0.4 and 0.6. Alright, so this is the conclusion that we should make okay, for part B. Alright, then let's continue to part C. So for part C, they want us to use this iterative formula to calculate the root correct to 2 decimal places, and all the iterations should be in 4 decimal places. Right, so first of all, this is the iterative formula requested in the question. Alright, so I have to use the calculator to help us and get the answer. Alright, so let me copy out the iterative formula first. Okay, so the iterative formula that we are having here is x n plus 1 equals to 1 over 2, then tangent inverse 1 over 2 sine 2x, right, minus 1. Okay, so when they give you the iteration formula, that means you can directly get the answer of the root by using the calculator slowly and try to find out all the iteration, then they will lead you to the correct root finally. Alright, okay, so to get the answer for this part, we need the help of calculator. Excuse me. Alright, so just try to use the calculator here. I will show it in this part. Okay, so our iterative formula is this one, right? So what we need to do is we have to key in the formula into this part. And first of all, you have to double check and make sure that your mode of the calculator is in the radian mode. So I'm having a flaw. Right, then after that, key in the right hand side of the equation into your calculator. So I'm having tangent inverse. Then with a fraction inside the tangent inverse, then it is 1 over 2 sine 2x. Then minus 1 and close bracket. Okay, then divided by 2. Alright, so now before we start the calculation, right, we need to decide the initial value. So for this question, they didn't mention what is the initial value that you should use. Therefore, you can use any initial value that you like. For me, usually I will refer to the value in part 2. How you get a sign change method, it is actually between the value of 0.4 and also 0.6, right? So I can use any value between 0.4 or 0.6. If you want to start with 0.4 also can. If you want to start with 0.6 also can. For me, usually I will just take the initial value that's within this range. Alright? Okay. So for me, first value I take 0.5. Where I take the center between the 0.4 and 0.6, right? Of course, you can try the other value. Slowly, you can see also the final answer that you get are the same. Right, so for x2, how to get the x2? Basically, it means that you have to substitute 0.5 into the right-hand side of your iteration formula. So you're having sine, then 0.5 times 2 is 1, then minus 1. Okay, so to get this value, we can use the calculator to help us since we already key in the formula. Okay, so please press calculate. Then they're asking you what's the value of x that you want to input. So we're having our first value of x is 0.5. So please click in 0.5, then press equal sign. Okay, this is the first value that you get. It is 0.485805. It's a long value. What we do is we cut it short into 4 decimal places because in this question, they did mention that your iteration should be in 4 decimal places. Alright, so for me, I'll put in 0.4858. Right, then after that, to get the next value for the x, you substitute 0.4858 into your iteration formula again. Okay, so for calculator, it's very convenient where you can directly press calculate again. Then you key in the 4 decimal answer, which is 0.4858, 0.4858, then press equal sign. Then the second iteration for the value that you get is 0.4967, correct to 4 decimal places. So 0.4967. What are we going to do now is we just try to continue and repeat the same process until you get 2 decimal places answer, which is repeated. Because our final answer did mention that, oh, your final answer correct to 2 decimal places, right? Therefore, for our iteration, okay, we can double check all our iteration until we get 2 decimal places answer, which is the repeated answer. Okay, right, so let's continue further. Now I want to input my x3 into the iteration formula, 0.4967. So press calculate, then key in the value 0.4967, then equal sign. Then you're having 0.4883. So 0.4883. Okay, continue further. Repeat again. Okay, so press calculate one more time. Then x is 0.4883. Press equal sign. Then you are having 4947. So 0.4947. Okay, then usually after a few iteration, right, I will double check and see what is the answer for 2 decimal places. For this one is 0.49. For this one is 0.50. This one is 0.49 again. Then this one is 0.49. It seems like your 2 decimal places answer has been repeated, right? Then if you want it to be safe, you can try to one extra iteration one more time. Okay, so what is the value of the next iteration? So press calculate again, then key in the value of 0.4947, then press equal sign. You're having 4898, so 0.4898. And if you double check again your answer, you are getting 0.49 again, correct to 2 decimal places. It means that your final answer for the root or for the x will be equals to 0.49. So again, to get this answer, just make sure every time your iteration, when you write out, it should be in 4 decimal places, according to the question, right? Then to check for the final answer, you check 2 decimal places answer until it is repeated. So this is how we solve question number 6. Alright, so we are now at question number 7. The equation of the curve is given like this, and then they want us to show that dy dx is equals to the expression. This expression on the right, yeah. Okay, so if you have a look for the equation here, basically you can't separate the equation clearly into y on the left, then x on the right. So what we are going to do now is we have to apply implicit differentiation. Okay, so let us carry out term by term. This is my original equation here. Alright, so for the first term, you're having 2y cubed. When you want to differentiate 2y cubed, just like how you differentiate last time, right? When you're having y power 3, you pull the power in front. So 3 times 2, you get a 6. Copy the y, power minus 1 become a 2. And because you are differentiating something related to y, right, with respect to x, so at the back, you have to put dy over dx. Then minus, okay, the second term here, we are having 2 bracket. It is a product of 2 function. Alright, so I treat the first bracket as 3x squared, the second bracket as y. So when we want to differentiate any function that is a product of each other, we have to apply product rule in differentiation. Right, so to apply the product rule, I need to copy the first bracket, differentiate the second. So I copy the first bracket first, 3x squared. The second bracket, I want to differentiate it, which is a y. So differentiate the y, you will get a 1. And because you are differentiating something related to y with respect to x, so we have to put dy dx at the back. So just now I copy the first bracket, differentiate the second. So now I need to differentiate the first bracket, copy the second. Differentiate the first bracket, 2 you pull in front, you'll be having 6x, power minus 1 become power 1. Copy the second bracket, y. So this is the product rule that we apply in implicit differentiation. After that, for the third term, you are having x power 3. So differentiate it just like what you did learn last time. So the power put in front become a 3. Copy the x power minus 1 become 2. And differentiate the constant term, you'll get a 0. Alright, then in our equation here, in the answer, they request us to have our dy dx on the left. So what do we need to do now is we try to group the dy dx at one side. Okay, let me expand all the bracket here first. So for me, I will want to factorize out the dy dx. Then I'm having 6xy plus 3x squared. Then I want to bring all the term to the right hand side and keep dy dx on the left. Right, then after that, we realize that basically we can factorize or simplify the 3. This is a 3, simplify it, 3, this is a 2. Then you get a 2, you cancel off the 3 here. That's why eventually you'll get the answer that they want you to prove. Alright, so this is how we get the dy dx. So you can double check your answer with what they want us to show is the same, right? Okay, then for part B, they want you to find the coordinate of the point on the curve at which the normal is parallel to the y-axis. So normal parallel to the y-axis. Let's have a look. What is the meaning of normal parallel to the y-axis basically? Okay, so if we are having a normal that's parallel to the y-axis means that your equation of normal is a vertical line, alright? And then the gradient for normal is basically infinity. Okay, so when you're having the gradient of normal equals to infinity, how can I link it with the gradient of tangent? Because when you're having the dy dx here, somehow this basically means that it is the gradient of tangent, right? Okay, so this one is having the meaning of gradient of tangent as well. How can I link the gradient of normal with gradient of tangent? Okay, so let's have a look from this part. Since I know that the gradient of normal is infinity, and we know also that gradient of normal multiplied with gradient of tangent should be equals to what? Should be equals to -1 because they are perpendicular to each other. If you try to imagine that you're having infinity and you bring it down, you're having -1 divided by infinity. So when -1 divided by infinity, which is a very large value, your gradient of tangent should be close to 0. Okay, right, so if gradient of tangent close to 0, that means I'm having the dy dx equals to 0. And what is my dy dx just now? So my dy dx just now is x squared plus 2xy divided by 2x squared minus 2y squared minus x squared equals to 0. Continue further, you'll be having this. Factorize out the x and try to solve for this equation. Okay, so from here you'll be having two values. X can be equals to 0 and also x can be equals to -2y. Right? Okay, so now you have to take note that these two answers here, these two values of x here, we denote two different points on the curve. So you cannot assume that they are one point, alright? So you need to solve for the value of x and y separately for these two parts of the x. Alright, okay, so how can I solve these two parts of the x here? Okay, so basically, you let x equals to 0, and you try to substitute it using the original equation. Alright, so substitute your x equals to 0 into this original equation, and let's see what do we get. So we are having 2y power 3 equals to 16. And very easily you'll get your y equals to 2. Alright, then after that the same thing happened for x equals to negative 2y. You also substitute it back into this particular equation. Right, so to get the second point. So the first point we get it very easily, where the first point is x equals to 0, y equals to 2. And now for x equals to negative 2y, you also substitute it into the original equation. So x equals to negative 2y will give you the original equation of 2y cubed minus 3. Then your x is negative 2y, right? So 2y squared multiply with y, then minus x cubed equals to 16. Alright, so substitute x equals to negative 2y into the original equation, this one. Okay, then we want to continue and solving this equation here. Okay, so if you don't do any careless mistake, you'll be having this. Okay, then negative 2y cubed equals to 16. So I think from here, very easily you will get y equals to negative 2. And therefore, what's the value of x if y equals to negative 2? So your y, substitute negative 2 here, you'll get x equals to 4. So from here, basically you'll get two answers, right? 2 points. The first pair of the point is this one, the coordinate, x equals to 0, y equals to 2. And the second possible point is this one. Alright, so you can rewrite your final answer again. The two coordinate or 2 points with normal parallel to the y-axis is 0, 2, and also 4, negative 2. Right? Yeah, so this is how we solve question number. Alright, so we are now at question number 8. They want us to prove this identity so that it is equal to the right hand side. Okay, right, so of course we want to start from left hand side because the left hand side is having 4x for the angle, so it's easier for me to expand it. Alright, so we'll start from left hand side where I'm having sine 4x. Right, so now our left hand side, right, all the angle is a single angle, so you can see that all of them are the x. But on the left hand side, we're having the 4x as an angle. Alright, so 4x, if you want to expand it, become the single angle, we might need to apply double angle formula multiple times. Alright, okay, so let's recall what are the identity that we are going to use for this case. Okay, so we are having the double angle for sine 2x. So sine 2x, if you want to expand it, you will get 2 sine x cos x. But in our equation here, on the left hand side, we are having sine 4x, which means that for this double angle, right, we need to change the 2x become 4x, and all the x here, we will need to make it become 2x. So which means that you are having sine 4x equals to 2 sine 2x and also cos 2x. We are allowed to play with the angle. Alright, so the double angle means that on the left hand side, the angle is double of the angle on the right. Okay, so we are having sine 4x. So we change our angle into sine 4x and we expand it become this one. Alright, so if I continue further, I will be having 2 sine 2x, then cos 2x. Alright, so next one. Now, if you have a look here, we are having sine 2x and also we are having cos 2x. Alright, so again, for sine 2x, we just use the original equation where you are having 2 sine x cos x. Alright, then for cos 2x, there are a few suitable equation that we can replace inside. Alright, then if you have a look here, basically you can see that everything is about the cos. So what am I going to do here is maybe I try to change the cos 2x into 2 cos square x minus 1. Alright, there are a few basically, because for cos 2x you still have 1 minus 2 sine square. Then we are also having cos square minus sine square. But according to my answer in the question, right, I have only sine power 1. So that means I try to avoid all the equation with sine square. Alright, so that's the reason why I choose this one, 2 cos square x minus 1. Right, okay, so if I try to replace it, 2 is a 2. Then sine 2x, I replace it by using 2 sine x cos x. Then for the cos 2x, I replace it by using 2 cos square x minus 1. Okay, then after that, if you double check again, I have 4 sine x in front of a bracket with the cos. So that means I keep the 4 sine x outside the bracket. Then for the cos x, I try to multiply inside the bracket. So if I try to multiply inside, very easily, you can see that we successfully get the answer that they want us to show. Okay, so this is the right hand side answer that we get. Alright, so just make sure that you are familiar with the double angle formula for sine and also the cos in this question. Then you need to know also that you are allowed to modify the angle according to what we have in the question. So this is what you have for part A. Then let's continue to part B. Hence, find the exact value of this particular integration. Alright, so let's start. Okay, so my integration is having pi over 4, then 0, then cos power 3, x, then sine 4x. Okay, so usually when you want to apply integration, right, if they ask you to do any proving in the previous part, very likely you need to use the result in part A and apply it in the part B. So if I have a look for part A, I'm having this sine 4x equals to this equation. So that means for integration, I need to substitute the result that I have into my integration. So cos power 3, I just try to copy it. Then I replace sine 4x become 4 sine x. Then 2 cos cube x minus cos x. Okay, so it looks like a bit complicated. Never mind, we try to simplify slowly. For me personally, I prefer to take out the constant 4 if you want. If you don't want, then never mind, you just multiply everything inside also can. Alright, so I want to expand the term first, where I'll be having 4, or 4 times 2, sorry. 4 times 2 is 8. Then sine x, then cos power 6x. Because you're having cos power 3, multiply cos power 3, right? So you get cos power 6. Same thing happen for the second term. You'll be having 4 sine x with cos power 4x. Okay, so next we need to learn how to integrate this particular part here. Alright, basically this integration, right, you need a special technique. Okay, and this technique is very similar to integration by using substitution. Alright, and how can we know what is the substitution that we need to use? So there's a small technique, alright, small technique that you need to try to observe the question, and you can see that what's the relationship between the sine and also the cos. You know that differentiate sine, you get a cos, right? Or you differentiate cos, you get negative sine. Okay, right. Then when you're having the higher power for the cos and the lower power for the sine, or the sine with power 1, basically you need to know that I want to use u equals to sine x. Because if I let u equals to sine x, I will be able to change this particular expression into a simple way of integration, for integration. Alright, okay, so basically it's like this. If let's say you are having any pattern with this, with power n, okay, then your substitution is you need to let your u equals to f prime x. Oh, sorry, you let your u equals to fx. Okay, alright. So this is a technique, but for integration or substitution, in the previous year, right, most of the time in the question they will give you directly the substitution that you need to use. Okay, but I realized that for these two series, yeah, there's one question that students need to know how to use the suitable substitution by themselves. All right, so I believe that in future they might have more questions like this. Okay, so you try to learn how to identify some simple example for integration for substitution. All right, so if you have see this pattern, f prime x multiplied with fx power n, then you always let your u equals to the fx. This is the substitution technique. All right, so like for our example here, I'm having sine x and also cos power 6. Cos power 6 is having a power, right? So this is like my fx power 6. Then the sine x is basically the prime, f prime x. Because you differentiate cos, you get negative sign, right? Yeah, okay. Then simply happen for this one, you are having fx power 4. And then you're having f prime x here. Okay, so these two integration, basically we are going to use the integration by substitution. Okay, so what I'm going to do now is I will let u equals to cos x. Alright, so what do you get for du over dx? So du over dx, when you differentiate cos, you get negative sign. Okay, and your du will be equals to negative sine x dx. Okay, so besides that, you also need to change the limit, right? So all the limit here are the x. So you're having the lower limit x equals to 0, and also the upper limit x equals to pi over 4. Okay, so you need to replace the limit as well. So if x equals to 0, what will happen to your u? So your u is cos 0. And then you're having 1. Okay? And after that, if your x is equals to pi over 4, then what will happen to your u again? So your u is equals to cos pi over 4. And then by right, you'll be having 1 over sub 2 lah. Okay, so if you want, you can keep it as 1 over sub 2. If you don't want, then you can make it become sub 2 over 2 also can. Alright, so you have to keep it in the sub form because for our question here, they requested for exact value for the integration. Alright, okay, so let us replace our substitution slowly into our original equation here. Okay, so I just try to copy it first. 0 and pi over 4 will become 1 and sub 2 over 2. We don't change the position of the limit, alright? So when 0 is at the bottom, so the 1 will be at the bottom. Okay, then for the first term here, okay, if I try to make it into the substitution, so let's have a look here. My du is equals to negative x dx. So I have negative sine x dx. I'm having sine x and dx. Okay, but I don't have the negative. So that means when I want to replace this, I will be having 8. Then cos become u, right? So I'm having u power 6. Okay, then the sine x and dx will become negative du. Alright, then this term is originally minus, right? So you also copy the minus first. Then you change the limit again from 1 until sub 2 over 2. Okay, so 4 is a constant. You just copy. Again, I'm having sine x dx, which is equals to negative du here. Okay, so sine x dx is negative du. So I'm having cos is u power 4. Then sine x dx, I'm having negative du. I want to put the dx and du at the back for the integration. So from here, you can see that my integration become much more simple. Okay, because this term looks very complicated, right? Okay, but after I use the substitution, my equation become very simple. Okay, so it become a simple integration. I'm having negative 8u power 6. So integrate u power 6, you'll be having u power 7 divided by nu power 7. Then you have to put in the limit of sub 2 over 2 and 1. Okay, then for the second term here, negative and also the negative at the back, multiply it together, become positive. Then you're having 4 u power 4. You want to integrate, become u power 5 divided by the nu power 5. Then you also want to put in the limit of sub 2 over 2 and also the 1. Okay, alright. So the technique of integration here is a bit more complicated because you yourself have to decide the correct substitution. Alright, okay, then let's continue further. I want to substitute in the limit, right? So I'm having 2 sub 2 over 2, okay, power 7 minus 1 power 7. Okay, then plus 4 over 5 is a constant, so I prefer to take it out first. Then I'm having sub 2 over 2 power 5, then minus 1 power 5. Okay, then now let us continue and simplify it. Sub 2 power 7. Okay, so you are basically having 2 square, sub 2 square for 3 times with 1 sub 2. So 2 times 2 times 2, you are getting 8. So you're having 8 sub 2 over, then the 2 over 2 power 7, what do you get? So 2 power 7, you'll be having 128 minus 1. Okay, then plus 4 over 5. For sub 2 power 5, you're having 2 times 2 times sub 2. This is sub 2 power 5. And then you're having 4 sub 2. Then divided by 2 power 5. So 2 power 5, you are getting 32. Then minus the 1. Okay, but of course, all this simplified part, you can use your calculator and simplify for you. Okay, all right, then after that, let us simplify everything now. Multiply negative 8 over 7 inside and simplify them. Then same thing happen here, multiply this inside and simplify them. Okay, all right, so I'm having negative 8 over 7 multiplied with 8 divided by 128. So I'm having negative 1 over 14 sub 2. Okay, then plus 8 over 7. Then for the next term, you try to simplify also. 4 over 5 multiply with 4 over 32. So you're having 1 over 10 sub 2 minus 4 over 5. So you need to know that this is for the blue color part and this is for the green color part, right? Okay, then after that, you can see that we can simplify and group the sub 2 all together. So if you assume that the sub 2 is an apple, so you're having negative 1 over 14 apple plus 1 over 10 apple. So 1 over 10 apple minus 1 over 14 apple, you're having 1 over 35 apple. Then the number and number, you add them together, 8 over 7 minus 4 over 5. So you're having 12 over 35. Okay, I think I made a careless mistake here, right? The value inside the search should be a 2, not a 5. Okay, then after that, me personally, I don't like the 35 as a fraction. So for me, maybe I want to take out the 35. Okay, then simplify, you'll be having 2 plus 12. Okay, so this is my final answer for this particular integration. Right? Okay, so just want to emphasize one more thing here. Okay, when you are trying to solve for the integration by using substitution, please make sure that you have the idea, right? How to use the simple, how to determine the correct simple substitution by yourself. Okay, because this question is not coming out for the first time. I remember that previously we did solve one question like this as well. So I believe in the future there will be more coming. All right. So you need to maybe try to learn from now, okay, how to determine or use the correct integration by using substitution by yourself. All right. Yeah. So this is how we solve question number 8. All right. So we are now at question number 9. We are given the function. Okay. It is a rational function, and then a is a positive constant. So they want us to express the function in partial fraction. Okay. So let's have a look. Whether do we have proper fraction or improper fraction? Okay, so first of all, let's have a look for the power, the highest power of x at the numerator. So we can see very clearly that it is x power 2, which means that on numerator, the degree of this polynomial on numerator is degree equals to 2. And when you try to expand the denominator, x multiplied with x, the highest power that you get is also x squared. This also tells you that the degree for the denominator is a 2. And when you are having the same power of the numerator with the denominator, or the higher power from numerator than the denominator, then basically it is improper fraction. So when you're having improper fraction, you might need to change your function into a proper fraction first before you can make it into the partial fraction. All right. Okay, so first of all, we need to apply long division first. Okay, so I'm having x squared plus 4ax plus 6a squared. Okay, so it will be our polynomial here, x squared plus 4ax, then plus 6a squared. And then for the denominator, let us expand it. If we expand it correctly, we will be getting x squared plus 5ax, then plus 6a squared. Okay, so not enough space. I rewrite it again, yeah. Okay, so basically, I just need to let you know that this step, a lot of students will usually forget. They will forget to check whether the fraction that they have is proper fraction or improper fraction. All right, so when you're having the improper fraction, you must go through the long division first. Okay, all right, so let's have a look for this one. I need to multiply something with x squared to get the x squared. So the something should be a 1. All right, so it should be a 1 here. So that 1 multiplied with x squared, you get x squared. 1 multiplied with 5ax, you're having positive 5ax here. Then 1 multiplied with 6a squared, you're having positive 6a squared. Then after that, you need to take the term above minus the term below. So x squared minus x squared, you get a 0. 4ax minus 5ax, you'll be having negative ax. And then 6a squared minus 6a squared equals to 0. For the remainder here, the negative ax, right, it will become the numerator of your remaining fraction. So I'm having ax negative divided by my original denominator. So what's the original denominator here? So you'll be seeing that it is actually x plus 2a and also x plus 3a. Yeah, so this is the fraction where we call it as proper fraction, because you can see the degree on top is degree 1 and the degree at the bottom is degree 2. Okay, when you are having the proper fraction, then only you can start to separate it or split it into the partial fraction. So please always remember this. Before you start to find out the partial fraction, always double check whether you are having improper fraction or proper fraction. To me, this is actually one of the common mistakes that a lot of students will do, right? Okay, so let's continue. You are taking the remainder divided by the divisor that we have, and we want to separate it into the partial fraction. And you are having linear factor, because this is x power 1, this is also x power 1, right? If you want to separate into the linear factor, you'll be having a over x plus 2a, then b over x plus 3a. Okay, so let's continue further. All right, so I multiply the whole equation by using the original denominator. So multiply the whole thing, the whole equation, yeah? Multiply the whole equation by using x plus 2a and also x plus 3a. Okay, all right, so if you multiply it, you'll be having negative ax equals to a with x plus 3a and also b with x plus 2a. Okay, so our aim now is to find out the value for A, capital letter A, and also the capital letter B. Right, so there are many ways for you to find out the value for A and B. You can compare it by expanding the right hand side, then compare it with the left. For me, usually I try to eliminate the unwanted unknown. So as an example, I will look at the linear factor, like for this linear factor x plus 3a, right? I'm trying to think, how can I make it become 0? So I need to let x equals to negative 3a so that this bracket becomes 0. Okay, then substitute x equals to negative 3a into your whole equation here. So negative a multiplied with negative 3a, you'll be having 3a squared, positive 3a squared. Alright, that equals to, substitute negative 3a here, plus 3a becomes 0, right? So 0 multiplied with a, your a disappeared. Then for negative 3a plus 2a, you're having negative ab. And we are looking for the value of the b, right? So the value of the b will be basically negative 3a. Alright, so you successfully get the value for b. And now let us continue with another linear factor. So let's look at this linear factor now, x plus 2a. How am I going to change this bracket become 0? So I need to let x equals to negative 2a so that this bracket becomes 0. Apply the same thing, substitute x equals to negative 2a into the whole equation. So negative 2a multiplied with negative a, you're having 2a squared. Negative 2a plus 3a become the a. So you're having a multiplied with capital letter A. So from here, you will get your capital letter A equals to 2a. Alright, so you successfully get the value for A and also the B. And now let us combine everything together, become the partial fraction. Alright, so my original function is x squared plus 4ax plus 6a squared divided by x plus 2a and also x plus 3a, right? Okay, so the quotient of the long division that we carried out just now, the quotient is 1. Basically, it is the first term without the fraction. Okay, then after that, the remaining part will be the partial fraction of your remainder with the denominator. So I already get the value for a and b, right? So to get the a is 2a over x plus 2a. And then for the b is negative 3a, so you're having minus 3a over x plus 3a. Okay, so this is basically the partial fraction that we have for this particular question. Okay, so just take note that it is actually a improper fraction. So you have to apply long division first before you carry out the process of finding out partial fraction. Okay, then let's continue further to part B. Right, so for part B, hence find the exact value. Please highlight the keyword exact. Okay, your final answer should be in the surd form or ln or pi or whatever. Okay, for this particular integration, give your answer in this form. AP plus ln Q, where P and Q are rational. So P and Q rational means that they are rational number. Okay, it can be a fraction, can be integer, right? But it cannot be decimal number. Alright. Okay, so let's start. For this integration, since we already find out the partial fraction just now in part A, right? Excuse me. Alright, then what should we do here is we want to use the partial fraction in our integration. Excuse me. Alright, okay, so let's start. Maybe I write my part B here. Alright, so I want to integrate negative a to positive a for the function. Okay, so for me, I will directly use the result of partial fraction that I get just now. Okay, alright, so all these are not something very hard to integrate. Okay, so let us start, yeah. If you need some recall, 1 is a constant, so very easy to integrate. 2a over x plus 2a, basically it is related to integrate 1 over ax plus b. So when you integrate 1 over ax plus b, then you will be having ln ax plus b. You bring up the ax plus b, then divided by differentiation of ax plus b, you get a, right? Then a constant term at the back. Okay, all right. So I don't like this one. Can I just move it up here? Should I move it? Okay, I put it here lah. All right. Okay. Yeah. So this is basically the basic idea of the integration. Okay. So let us start. If I want to integrate the 1, I will get the x. 2a is a constant, so I just try to copy it first. For the bracket of x plus 2a, if I integrate, I will need to bring it up, become ln x plus 2a. Differentiate x plus 2a, you'll be having a 1, so you actually need to divide it by 1. Okay, so since it is divided by 1, so I don't need to write out, right? Okay, so I will be having 2a with ln, then x plus 2a. Same thing happened for the last term here. Negative 3a is a constant, so I just try to copy it. Then bring up the bracket, become ln x plus 3a. Differentiate x plus 3a, you have a 1, so you have to divide it by 1. I didn't write out here, right? Okay, so after you complete your integration, then just try to substitute your value inside. Okay, substitute the a first. If I want to substitute the a into the x, so I'll be having a plus 2a, then ln a plus 2a is 3a. Okay, then minus 3a, then ln x plus 3a, a plus 3a is 4a. Okay, then after that, I have to substitute the negative a, right? So when I substitute the negative a, I have to minus. Okay, substitute negative a into the x, you'll be having negative a, then plus 2a ln negative a plus 2a, you'll be having ln a. Then ln negative a plus 3a, you're having ln 2a. Then next step, you need to very carefully simplify your answer into the form that they want. So don't forget, they want us to have this form, yeah, a bracket b plus ln cube. Okay, so before I can combine them, I just try to expand everything first. Okay, so I'm having 2a ln 3a minus 3a ln 4a, then plus a, minus 2a ln a minus 3a ln 2a. Okay, all right, so next, what can we do now? We try to combine all the term without the ln first. So a plus a, you are having 2a, right? Okay, so you're having 2a here. Okay, then after that, I want you to have a look for this particular term. I'm having 2a ln 3a with negative 2a ln a. So from here, right, you can factorize out the 2a first. Then you'll be having ln 3a minus ln a. Ln 3a minus ln a, you can write become ln 3a divided by a. Okay, so basically this is what we have. Then after that, for this particular part, negative 3a ln 4a and also negative 3a ln 2a, I want to factorize out the negative 3a first. So if I factorize out the negative 3a, right? So what do I have here in this case? Okay, so before I continue, I realized that I made a careless mistake. This one should be a plus, not a minus. So sorry for that. Alright, so I factorize out the positive 3a. Then I will be having ln 2a minus ln 4a. So ln 2a minus ln 4a, I can combine that become ln 2a over 4a. Okay, all right. Then what else can I do from here? Okay, then let us simplify something that we can simplify first. A and A can be simplified here. A and A can be simplified here. Okay, so I'm having 2a plus 2a ln 3 plus 3a ln half. Okay, I need to still further simplify them. And in your answer, right, you can actually see very clearly that you're having the A in front of anything else. So that means we should try to factorize out the A here. Then I'm having 2 plus 2 ln 3 plus 3 ln half. Okay, then the 2 in front of the ln, you can bring it back, become the power. So you're having 3 square here. So 3 square is a 9. Same thing happen. For the 3, you can bring it back, become the power of the half. So half power 3, you will be having 1 over 8. Next, you can combine the two terms of this ln together. When you're having ln A plus ln B, you can combine that, become ln A times B. So ln 9 times 1 over 8, you'll be having 9 over 8. Okay, so you double check and see whether is this the pattern that they requested in the question. So basically, yes, because you're having A in front, then your P is actually the 2 and your Q is 9 over 8. All right. Yeah, so this is how we solve question number 9. Okay, so question number 10. We are given a diagram, show a tank for holding water. So the tank is in the shape of a cube. Then each side is having 50 cm. At the time t, the depth of water in the tank is h cm. Water is poured into the tank at the rate of 50,000 cm cube per second. Water pours out of tank through a hole in the bottom at the rate proportional to h squared. Alright, so for this question, they said when h equals to 20, the depth of the water is increasing at the rate of 0.4. Then what they want us to find here is they want us to show that dh dt is equals to this particular value. Alright, okay, so first of all, we need to know first how can we get the dh dt when we are having something that's related to the rate of change. Alright, so first of all, to get the dh dt, you might need to apply the chain rule where this question they are talking about the volume because they said water is poured into the tank at the rate of 50,000 cm cube, right? They are talking about the volume. So we try to form the equation that's related to volume. So we are having dh over something multiply with something over dt. So like what I told you just now, it is related to volume. So we are going to use the dv here. Right, so our chain rule to apply to get the dh dt will be dh over dv multiply with dv over dt. Okay, so before that, let's have a look for the question again. I want you to have a look for this particular question here. The sentence here, sorry, the last sentence here. Water is poured into the tank at a rate of 50 cm cube per second. So they are talking about the rate of volume increasing, right? Therefore, for this particular sentence, if you try to write out your value, okay, or your equation, you'll be having dv over dt. They are talking about the rate of change for the volume. All right, and basically it is 5,000 cm cube per second. But at the same time, they say water pour out of the tank through a hole in the bottom at this rate. So pour in means it is increasing. So increasing, you should be having a positive value. But when you are having pours out, that means the water is leaking, right? So that means the volume become less or decreasing. So when you're having anything that's decreasing, then you must have a negative. Proportional, you don't know what is the value for the proportional yet, so you just put it as a k. Then proportional to h square. So you're having h square here. This is the dv dt that I can get from the sentence that I highlight in red color. Okay, right. So this is what I get for dv dt. And then, so you can see from here that we already have the one part of our chain rule, dv dt is already here. Okay, then now let's have a look for dv and dh. How can we link volume with the height? Okay, so for this particular diagram, to get the volume, it is basically the area of the base multiply with the height. So the area of the base is 50 times 50, so you should be having 2,500. Agree? All right. Then after that, you're having multiply with h so that you can get the volume. And from here, this equation, if you continue to differentiate it, with respect to h, then you'll be having dv dh equals to 2500. All right. Okay. So from here, you already can see quite clearly that we already get all the component that we need in the chain rule. Okay, we have dh dv, we also have dv dt, and let us combine all of them together, okay, to get the dh dt. All right, so I'll move it down now. All right, so to get the dh dt, yeah, like what I told you just now, we are going to apply the chain rule, right? So dh over dt, basically it is dh dv. dv dh is 2500, so dh dv will be 1 over 2500. Then multiply with dv dt. So this is the dv dt that I have. I'm having 5000 minus kh squared. So this whole term must be multiplying with 2500. Okay, and now we actually need to find out the value of the k. All right, the proportional rate, the k. So how can I find the k? Let's figure out the useful information provided in the question. They mentioned that h equals to 20. The depth of the water is increasing at the rate of 0.4. So this particular sentence basically tells us that when h is equals to 20, the depth means the h, so dh over dt is increasing. They are talking about the rate of change for the height. Okay, that is increasing at 0.4. Okay, so we are going to use this information in our equation here, okay, to get the value for the k. All right, so given that h is equals to 20, all right, so I want to substitute this value into my equation here. dh dt is 0.4 equals to 5000 minus k, then h is 20, right? So you're having h squared, means 20 squared, divided by 2500. Okay, so if you try to simplify your equation, you'll get actually the k equals to 10. Alright, so if I rewrite my equation again, dh over dt then I can simplify all the term by 10. And I think this is how you already get the answer that they want you to prove. Alright, okay, so this is what we have for part A. Then let's continue to part B. Okay, for part B, given that h equals to 0 when t equals to 0, find the time taken for the depth of the water in the tank to reach 20 cm. Okay, so before we can find out the value of h, okay, when the value of t when the h is equals to 20, you actually have to solve this differential equation first. All right. Okay, so let's solving the differential equation first. Okay, I'm having part B here. Right, so I have my equation, my differential equation. Okay, so this is what I have. Alright, so to solve the differential equation, you need to move all the variable, the same variable at one side. Okay, so as an example, I'm having dh and dt, right? There are two variables here. I want to group all my h on the left. So that means for this particular 500 minus h squared, I want to bring it over to the left hand side. It will become 1 over 500 minus h squared. Then I keep the dh on the left. Then I'm having 1 over 250 dt on the right. Okay, so from here you can see very clearly that we are having all the variable h on the left, then all the other variable related to t on the right. So you successfully separate all your variable, then you can start the integration. Okay, so this integration is very easy because it is just a constant term. Alright, then for this particular part here, I will want to make it become 1 over square root 500 square, because the 500 square can be written as square root 500 square minus h square dh. Okay, then some students, when they look at this one, they already can try to link that, oh, this integration, right? Basically, you can separate it into the partial fraction, then only you carry out the integration. But this is too long because they only give you 5 marks here. For this particular question, right, actually you are allowed to directly get the integration formula from our formula booklet. Alright, so you can have a look for our formula booklet, the MF19. This MF19 under the integration part. Okay, you can see that I want to compare it with this particular formula. So that means what do we have here is they said if you have integrate this one, okay, your final answer will be this. Alright, so let me try to copy it back to our question just now. Okay, so what do we have here is this one. Okay, here, yeah, so that you can see clearer. Alright, so that means if you want to integrate 1 over x squared minus a squared, right? Let me have a look, yeah. Do I copy the wrong equation? Let me double check again. Oh, sorry, I think I copied the wrong formula because we are having the variable here is square root 500 square minus h square. So the variable is at the back. I should be having a square minus x square. So sorry. This one is a wrong formula. Okay, so I go back to the formula booklet. Okay, then now I'm looking for this particular part. This one, a square minus x square. All right. Okay, then let me copy it back here. Okay, so under this part, according to this formula, right? Basically, you can see that if you want to integrate 1 over a square minus x square for dx, excuse me, then your answer should be 1 over 2a ln a plus x over a minus x modulus. Okay, then of course we need to figure out, yeah, what is the a in our question here. So if you have a look for our a here, a square, I'm having a square minus h square. So that means the a here basically is square root 500. Okay, all right. Then now, if I want to continue with my integration by using the formula directly, integrate 1 over x square minus h square, a square minus h square, you should be having this one. So let us try to copy out the answer on the left. It will be 1 over 2a. So 2 multiplied with square root 500, then log a plus x. So you're having square root 500, which is the a, plus x, but I have to write it out as plus h here because our variable is in terms of h. Then divided by a minus x. So square root 500 minus h. Okay, so this is the answer for left hand side. Then equals to integrate, excuse me, 1 over 250 is a constant, right? Then you're having 1 over 50t with a plus c at the back. Okay, alright. So just to let you know that you are allowed to actually apply the formula directly from list MF19 for this particular integration. Okay, alright. Then let's continue further. I need to get the value of the C, the constant term. There are some students, right, they will ask, where should I put the constant term C? Should I put it on the left or on the right? So basically, you can put it on either side, but we only put it at one of the side. So that means, although I know that there's a constant term here, but I just try to move it to the other side and group everything on the right for my habit. Okay, but some students, they prefer to keep everything, all the constant term on the left. Also cannot, no problem at all. All right, okay. So no worry where to put the constant term. So you can just put it anywhere, but just make sure that you put it at one side. So assume that you are trying to group all the constant term at one side only. All right. Okay, how to get the C? Again, they will give us the initial value when h equals to 0, t is equals to 0. Okay, so let's continue from here. Given that h is 0, t is also 0. What will happen to our equation here? We'll be having 1 over 2 square root 500 with a ln 1. That equals to 0 plus c. And the ln 1 is basically a 0 as well. Therefore, your c is a 0. Okay, then eventually your equation will be something like this. Right? And this is not the end of the question yet because they're asking the time taken for the depth. The depth means h. The depth of the water in the tank to reach 20 cm. So that means they're asking if let's say h is equals to 20, what will happen to your time? Okay, so you just try to substitute 20 into your equation, your particular solution here. So square root 500 plus 20 divided by square root 500 minus 20. Then equals to 1 over 250 t. So try to use calculator to help you simplify this particular phrase. Then multiply, bring the 250 over. That means you multiply the 250. Okay, and see what you get here for the t. By right, you should be getting a very long value for t. Alright, so I'm having t equals to 16.14 something. Then of course, we will want to correct it to 3 significant figure. Answer should be 16.1 seconds. Correct to 3 significant figure. Right. Okay, so this is how we solve this question. And there's one part that I want to remind students where this part, because for recent year also I realized that there are 1 or 2 questions. When you want to try to find out the answer for integration, right, I realized that it is something that we are not so familiar. So as an example, like for this one, right, I basically didn't teach my student how to integrate it. But of course, if you want, basically have to apply partial fraction. But the step is very, very long. Okay, then when I read through the marking scheme, I realized that, oh, basically they allow us to directly use the result in our formula booklet to get answer for this. Okay, so maybe you can make it as a habit. When you are seeing something not so familiar for you to integrate with, maybe you can try to figure out and see, is there any formula in the list MF19 that is suitable for you to apply in your solution? Okay, so I think this is one of the questions because for me personally, when I solve this question, right, I apply partial fraction and the step is really, really long and also very tedious. Okay, so to make it easier, you can directly apply the formula from the list MF19. Okay, so this is just a small reminder for you all. Right, this is how we solve question number 10. Okay, so question number 11, the last question for this paper. Relative to the origin O, the position vector for the point A, B, and C are given like this in the vector form. So the midpoint of AB is M. as shown in the diagram. So you're having midpoint, M is the midpoint of AB. Find the vectors of MB and also MC. Okay, so first of all, if I want to find out the position vector for M, you need to find out the coordinate for M first. Alright, okay, so just a reminder, for the midpoint, usually in the vector form, I will want to use coordinate geometry to find out the midpoint. To me, I feel that it is easier. Okay, alright, so for A, you're having a coordinate geometry of 4, -2, and also 0. Because you're having 4i minus 2j, right? So your 4, -2, and 0. Then for B, you are having 2, then 8, and also the 4. And to find out the M, which is the midpoint, to find the coordinate of M, what you need to do here is you just try to use x1 plus x2 divided by 2. So I'm having 4 plus 2 divided by 2. Okay, then 8 minus 2 divided by 2. Then 4 plus 0 divided by 2. And from here, you'll get your M coordinate as 3, 3, and also 2. Excuse me. Alright, then after that, only you change it become the position vector. Right, so in my opinion, this is basically the easier way for us to find out the position vector of a midpoint. Alright, so I just want to let you know a common mistake that the student will do usually. Usually, the common mistake that students do is when they say, oh, the midpoint of AB is M, right? So what they do is like they always take OM equals to half of AB. And I just want to tell you that this is basically wrong because half AB is actually AM, not OM. Okay, so if you want to get the position vector of M, to me, the safest way is by using the coordinate geometry formula to find the midpoint first. After that, only you change it become the position vector form. Okay, all right, so this is a common mistake that I see very often. All right, okay, so just a small reminder here. Okay, then after you find out the OM, the position vector of M, then you can find out the vector for MB and also MC. So let's start. Right, so to find out the MB, of course, you need to have many ways for you to do it. Okay, so you can, to find the MB, you can use MO plus OB. Okay, so what's your MO? So MO is -3, -3, and also -2. Then what is the OB here? So OB here, if you have a look for our position vector, it is 2, 8, and 4. Then if you try to simplify them, you will be getting -1, 5, and also 2. This is your MB. Alright, then of course, if you want, you can just make it into the IJK form. Okay, then after that, let's have a look for what they want. They want us to have MC, right? Okay, so to have the MC, you need to have MO plus OC. Okay, again, my MO is -3, -3, -2. Then plus OC. OC that I get here should be -2, 0, and also 6. So -2, 0, and 6. Okay, so if you try to simplify them, by right, you'll be having -5, -3, and also 4. Okay, so I write into the IJK form, I'll be having -5i minus 3j, then plus 4k. And this is my MC here. Okay, so we're done for part 1. Then let's have a look for part 2. Calculate the exact value of the cosine of angle CMB. Oh, so they're asking for the cosine of the angle. Alright, so for the angle CMB, if you try to have a look, the angle CMB, if I have a look for the diagram, C, M, and also B denote this particular angle. This one. Okay, so this particular angle here in blue color. Alright, so CMB. To calculate the cosine, the angle here, you need to use the cosine rule. And you have to make sure that the both vector that you are using is going out from the angle. So you should be using MC to and MB. Alright, for the cosine rule. Alright, so you should have MB dot MC equals to the modulus of MB and also the modulus of MC, then cos theta lah. And the theta basically means the angle CMB. Alright. Okay, so let's find out the dot product. So I'm having MB is -1, 5, and 2. MC is -5, -3, and 4. Modulus of MB and also MC. So let's see what do we have here. So -1 square plus 5 square plus 2 square. MC is -5 square plus -3 square plus 4 square, right? Okay, then you're having cos theta. Okay, so continue further. For dot product, so -1 times -5, you're having a 5, then -15, then plus 4 times 2 is the 8. Then on the right hand side, you're having square root of 30, then square root of 50. Okay, then cos theta. Alright, so the value of cos theta that we have here basically is -2, then divided by square root of 1500. Okay, so this is basically the value of the cosine of the angle CMB. Alright, but of course, some students, they will rationalize it. Okay, so if you try to rationalize this one by using the calculator, then you should be having negative square root 15 over 75. This is after rationalize it, okay? So if you keep the original value, it should be -2 over 1500 square root. This is what we have for part B. Okay, then now they want us to find the exact area of the triangle ABC. Okay, highlight the keyword exact area for the triangle ABC. So let's have a look for the diagram again. Triangle ABC means that this part, right? Okay, and from here, I know that this is basically the theta. To get the triangle ABC, it will means you need to use this triangle, add another triangle, area of the triangle, which is this one, blue color and also the purple color. Okay, alright, so let us start first. Okay, so I'm having part C now. Okay, if I try to write out the step, so basically what I want to have here is to get the area of triangle ABC, I want to use area of triangle CMB plus the area of triangle CMA. Oh, then the area of triangle CMB I'm using blue color lah. Then CMA I'm using the purple color. Alright, so maybe I change it a bit. This one is the blue color so that later you know what am I doing. Okay, so blue color is area of triangle CMB. Then the purple color is area of triangle. And now, how can I get the area of the triangle CMB? So what I want to use is I want to use the formula for that involve the sine theta. So I want to have half A, B, then sine theta. Okay, so I hope that you can see clearly. Yeah. Right, so what I have here is I'm having half AB sine theta. So the AB means the length for MC and also the length for MB. Then I'm having sine theta. Okay, then after that, for the purple color area, I also want to apply the same thing. I want to use A, B, then sine C, this one. So this area, this angle is 180 minus theta. Correct? Because this whole thing is a 180 degree, it's a straight line. Okay, alright. So half A, B, sine C. So my A and B is MC and MA. Alright, so I write it out. Half MC, MA, then sine 180 minus theta. Okay, then if you try to have a look for the details here, right? Just now I get the value for cos theta. How can I get the value for sine theta? You might need to draw a diagram to help you. Okay, so from here, cos is having a negative value. So you know that the theta basically is an obtuse angle. Then the value of cos is negative 2 over square root 1500. So that means, excuse me, my adjacent length is negative 2. My hypotenuse should be 1500. Okay, so we need to find out the opposite length. The opposite length should be 1500 minus 4. Then square root. So you'll be having square root of 1496. Okay. Excuse me. Then this one is 180 minus theta. Okay, so we are referring to this triangle to get the value for sine theta, right? Okay, so half. What's the length for MC? You already get your length of MC just now, which is this one, square root 50. What's the length for MB? This one, square root 30. Excuse me. Then what's the value for sine theta? So sine theta means opposite over adjacent. So you're having square root of 1496 divided by the square root of 1500. Okay. Then after that, for the purple color part, also the same, half. What's the length for MC? Square root 50. What's the length for MA? Because M is the midpoint of A and B, right? So MA and MB should be having the same length. So it should be equal to square root 30. And then what's the value for sine? 180 minus theta. So in the second quadrant, sine 180 minus theta also positive value. So according to the same triangle here, it is still a square root of 1496 over 1500. So you can see that these two terms basically are the same. Alright, so half something plus half something, you are getting a 1. Okay, then we try to simplify the term here. Let us make everything into a square root. Okay, so I'm having 50 multiplied with 30 multiplied with 1496. So I'm having a super large value, 2244000. Then divided by 1500. Okay, then after that, what do I have here is, oh, actually I no need to do it, so I'm too stupid, sorry. So actually I can directly simplify it because half and half add together become 1, right? Then square root 50, square root 30 can be simplified with square root 1500. Alright, so from here, you are having 2 times of square root, oh sorry, this one also simplified already, right? So you're having square root 1496 and square root 1496. You're having 2 times of square root 1496. Okay, then you try to use calculator and help you to simplify a bit. So the square root 1496, you will make it become 2 times of 2 square root 374. Sorry, wait, there's a careless mistake here also. I'm having half. Oh, okay. So I'm having half. So half plus half, half square root 1496 plus half square root 1496, you're having 1 square root 1496. Then if you try to further simplify it, you should be having 2 square root of 374. They're asking for exact value, so you can see that I try my best to rephrase it into the third form. Alright, yeah, so this is how we solve question 11. And then to me, I actually spent quite some time to get the correct answer. It is because of the triangle that I draw here. I realized that if I try to rationalize my answer for cos theta, and I use my rationalized answer for the triangle here, my calculator not able to help me and simplify to get this particular value. They will give me the non-exact area. Alright, so to make sure that you can get the non-exact area, my suggestion is when you are trying to draw the triangle, you use back your original value for cos theta, which is before rationalization. Then you can simplify in the easier way. Okay, all right. Yeah, so this is how we solve question 11. Thank you very much for watching the video.